Welcome to Spatial Patterns in Gold Deposits for the Bendigo-Ballarat region, Victoria, Australia. This presentation has been prepared as part of the research effort titled The Spatial and Temporal Distribution of the Metal Mineralization in Eastern Australia and the Relationship of the Observed Patterns to Giant Ore Deposits. The geology of southeastern Australia, called the Lachlan Fold Belt. Between 1851 and 1895, the Bendigo-Ballarat goldfields produced more gold than any other goldfield in the entire world. The Bendigo-Ballarat area has produced more than 2,000 tons of gold. There are clusters within clusters for the gold deposits of southeastern Australia. There are patterns within patterns. These are the Bendigo-Ballarat goldfields. Note the scale, and this is the technique employed by prospectors is looking for the next gold deposit along trend. To recognize the clustering of the patterns within the Bendigo-Ballarat region, we are implementing the AutoClust algorithm. This algorithm is near ideal in that it automatically extracts boundaries based on Voronoi and Delaunay tessellations. It avoids human bias. Parameters are not specified by the users in this automatic clustering. The M value shown in the following slides designates the lengths of edges in units of standard deviation away from the global mean, which are included in a single cluster. The global mean is determined from edges in the entire data set. The noise index of a point P is the ratio of the local mean over the global mean, where local mean is determined from the mean of points with edges incident to that point P. The noise index is a measure of the deviation of any single point from proximal points. The mean of edges incident to noise tends to be significantly greater than the global mean. The M value can be used as an exploration tool. Larger values of M causes relatively close clusters to merge into the same cluster. Smaller values of M result in clusters with more homogeneous lengths of edges. Smaller values of M identifies relatively high density clusters and homogeneous clusters, but declares relatively sparse clusters as noise and heterogeneous clusters as potential outliers. The user may reduce the value of M to find breakable or vulnerable regions in clusters where they are about to split. The gold deposits that were clustered in the Bendigo-Ballarat region. The following images show polygonization of gold deposits in the Bendigo-Ballarat region at various M values with 0% noise. One will notice that there is an optimum M value for clustering, after which information is actually lost. The optimum M value for clustering in the Bendigo-Ballarat region is 1.1. Clustering with an M value of 1.1. Polygonization with radial trends. Note that there are no gold deposits at the very center of the radial pattern. This is a characteristic of many, if not most, of the approximate 80-kilometre diameter clusters in southeastern Australia. The giant and major gold deposits in the Bendigo-Ballarat region. Generally, the giant and major gold deposits in southeastern Australia occur proximal to the empty centre, with the small deposits occurring primarily in the radial zones. However, for the Bendigo-Ballarat region, this appears not to be the case. The explanation may be in the very shape of the radial patterns for this region. Note the tails on the ends of each radial zone, indicating that the entire pattern was rotating at the time of gold deposition. Rotation may have created unique deposition sites to circulating hydrothermal fluids. Both Meyerhoff and O'Driscoll have suggested that vortices, similar to those seen in the Earth's atmosphere, can exist in the mantle. The following time sequence shows diagrammatically the proposed anti-clockwise rotation created by the Earth tide forces for the southern hemisphere. The Bendigo-Ballarat model. Bostrom shows that earth tide forces acting on a convecting mantle would cause the material to rotate in an anticlockwise motion in the southern hemisphere. Earth tide is the sub-meter motion of the Earth of about 12 hours or longer caused by moon and sun gravitation. These forces induce cumulative vorticity in an imperfectly elastic mantle. Thank you. References.